Welcome to Saitechinfo channel, my dear students. In today's session, I'll be discussing about the chemical properties, the remaining chemical properties of alcohols and phenols, and I will also include the dihydric alcohols and trihydric alcohols, that is ethylene glycol, that is glycols and glycerols. So I will include that one also. Okay, right. So I asked a simple question to start with this session to recap whatever we have discussed in the previous sessions. Can you answer that question? The starting compound for preparation of secondary alcohol from Grignard reagent. For secondary alcohol, it is not formaldehyde. Formaldehyde is for primary alcohol. So for secondary alcohol, it is acetaldehyde. For tertiary alcohol, acetone. So you have to remember, please go through. I give enough time, Right. If you don't practice, definitely you will forget everything. So practice daily. You have to write down the reactions. Compulsorily you have to write down and practice. You cannot simply read chemistry and mathematics. So practicing this kind of reactions will be very useful to you. Okay, so let me continue the next topic. And before discussing the remaining part of alcohols and phenols, I want to introduce the glycol simultaneously. Okay, right. Can anyone tell me the IUPAC name of glycol, ethylene glycol, CH2OH? You can quickly type. Otherwise, I'll give the answer. Ethylene glycol. Similarly, can you name this compound? CH3, CHOH, CH2OH. And as I already mentioned, this can be represented as HOH. It is understood here you have H. Otherwise, this can be represented as simply OH. That's all. And similarly, this one can be represented as OH. Now, what is the name of this compound? Ethane 1,2-diol. That's good. So, ethane 1,2-diol. And similarly, the next molecule, that is called propane 1,2-diol. Okay. So, propane 1,2-diol. So, this is ethane 1,2-diol. And this is propane 1,2-diol. Right? Okay. So let us see some of the trihydric alcohol also. So name this compound. It is glycerin or glycerol. Okay, so this is propane 1,2-diol. And what is this structure? What is this name? CH2OH, CH2, then CHOH. Name this compound. This is propane 1,3-diol. That's all. What is that? Propane 1,3-diol. Here it is 1,2-diol. This is 1,3-diol. Okay, no doubt. Diols are isomeric with ethers or hydroxy ethers. Let me explain about this. Take down. It has the functional isomerism. Diols have functional isomerism. Functional isomerism. What do you mean by functional isomerism? Two different the structure formula are exhibited by which of change in the nature of the functional group. Let me say that is CH3, CH, OH, and then CH2, OH. You know very well, this is propane 1 Please check now. Is it okay? Please check the audio. Is it okay now? Right. Let me proceed. So I was discussing about the dihydric alcohol, that is ethylene 1,2-diol, ethylene glycol, and propylene glycol, and this is known as CH3CHOH CH2OH. So propane 1,2-diol, and this one is 1,3-diol, propane 1,3-diol, and these structures can be simply represented like this also. Okay, right. And let me move to the functional isomerism exhibited by diols. Please make a note. Functional isomerism exhibited by diol. As I already explained, the functional isomerism, that is, the same molecule can be represented in two different structures by the difference in the nature of the function group. Here the function group is diol, but the same compound here, it can be written as CH3 O CH2 O CH3. So this is called dimethoxymethane. That is, this is methoxy, another methoxy, and this is methane. Okay, so dimethoxy methane, dimethoxymethane. And you have methoxyethanol also. Listen, CH3 O, this is methoxy, and then you can put CH2 and then OH. So this is methoxyethanol because this is ethanol. You know, this is ethanol part where methoxy is joined here. So this is called methoxyethanol. Do you understand? Now in all these aspects, let me work out the molecular formula. How many carbon atoms are there? C3. And what about hydrogen? 3 plus 1 4 plus 2 6 plus 2 8. And what about oxygen? O2. And you just count here 1 2 3. So C3 and H 3 plus 2 5 plus 3 8, and then O2. So similarly this one. So it means the same molecular formula can be represented in three ways like this. Okay, please note down. And this is because of the difference in the nature of the function group. Here the function group is hydroxy group, that is 2-hydroxy group, that is diol, whereas here it is dimethoxy, that is ethereal part. So here one ether, one hydroxyl group. So likewise you are able to, this is a wonderful example of that is displaying this functional isomerism. Okay, please note down. Do you understand this? There are two oxygen, O2, and here also O2, then O2. So C3H8O2. Right, good. Now let us move further. I hope now you should be able to understand the diol and its isomeric form. Okay. let me give you some molecule. Try to give me the IUPAC name. CH3 O CH2 O CH3. I said this is dimethoxymethane. Then what is the IUPAC name for this? I mean, this is IUPAC name. This is IUPAC name. Can you call it by any other name? See, CH3OCH3 is ether, dimethyl ether. In in first carbon atom, CH3O has been substituted. So it can be called that is a methoxy dimethyl ether. Okay, but the more appropriate name is dimethoxymethane. That is by IUPAC convention. Okay, now what is the IUPAC name of benzyl alcohol? As and when required, we had to check the naming system. This is known as benzyl alcohol. You know very well, this is phenol. So this is enol, that is phenol, whereas this is alcohol. So this I already explained. But what is the IUPAC name of this one? This can be called, this is methanol, so phenyl methanol. Okay. Phenyl methanol. See, some of the old students have given the sketch note. So you can also prepare like this for the preparation of alcohol. Let me reproduce, but you can do it in a better way. Okay, you please note down. You watch the video later and note down and reproduce in a better manner. So this is one of the sketch notes prepared by our old Saitech students for preparation of alcohol. So alcohol classification, physical properties, nomenclature, all these things have been brought in one page as a cheat sheet. So you can also try later. Similarly for phenol, they are done wonderfully. So this is the another sketch note, they have done it for phenols. And then for ethers they are done wonderfully. This is for ethers. So just by preparing all these sketch notes, you will be very comfortable to memorize. So try to produce this and let me publish in our website. Okay. So you can note down later. These are all very simple. Now let me talk about the properties of benzyl alcohol. Properties of benzyl alcohol. Check down. So when you consider the physical properties, they are colorless, and it has got some pleasant smell. It's a pleasant smelling liquid. Its boiling point is 478 Kelvin. And they are sparingly soluble in water. Sparingly soluble in water, and it has OH group, so it is hydrophilic. Hydrophilic means that is it can associate with water. So hydrophilic. Then the phenyl group is hydrophobic, and that is why it's sparingly soluble. Do you understand this? Phenyl group is hydrophobic. So that is why it is in between. That is sparingly soluble, partly soluble. However, it's soluble in organic solvent like benzene, toluene. Okay. And this can be called by IUPAC as phenylcarbinol also. Take down. Phenylcarbinol. Okay. And it has various derivatives like benzyl alcohol has various derivatives like anizole. So anizole, which is nothing but C6H5 OCH3. You can draw like this. So this is anizole. Similarly, you can have cresol also. So cresol has this structure, that is hydroxytoluene, orthohydroxytoluene. So orthocresol. And you can have orthocresol, metacresol, paracresol, and a combination of all these cresols can be called a cresolic acid. Preparation of benzyl alcohol. Preparation of benzyl alcohol. This can be done by, you can start from toluene. So what is the formula for toluene? Methyl benzene. Now it is subjected to chlorination. so that you can get benzyl chloride. The side chain is chlorinated, CH2Cl, and then it is subjected to a reaction with NaOH. As I already mentioned, Na has affinity towards Cl, so you can remove NaCl and the hydroxylation takes place, occurs. So you have now CH2OH, right, benzoyl alcohol. And it can also be prepared from aldehyde. You can reduce the aldehyde, is it not? So take benzaldehyde. So this is one method. Another method is you can reduce benzaldehyde. This is benzaldehyde, CHO, benzaldehyde. And on reduction using lithium aluminum hydride, so that you are able to get CH2OH. What is that? Benzyl alcohol. Other reducing agents can also be used, like that is zinc, HCl, etc. You can also use sodium amalgam. So other reducing agents. And this can be prepared by Cannizzaro reaction. So what are the other reducing agents? Sodium amalgam, please note down. Sodium amalgam and zinc HCl. Okay? Right. There is another very important reaction that is called Cannizzaro reaction. Okay, this is one of the frequently asked questions. Cannizzaro reaction. And you can anticipate some problems based on Cannizzaro. So here, let us have C6H5CHO. This is benzaldehyde, right? So 2 moles of benzaldehyde. What is that? 2 moles of benzaldehyde. Let us consider 2 moles here. 2 moles of benzaldehyde can be subjected to hydrolysis, that is alkaline hydrolysis, in presence of OH minus. So you are able to get, that is, one is a reduction product, that is CH2OH. This is a reduction, is it not? Aldehyde becomes alcohol, is it not? So this is a reduction product. Another is an oxidation product. So here the funniest thing is, on the product side you can have reduced product as well as oxidized product, and that is the speciality of Cannizzaro reaction. Do you understand? So this is the reduced product and this is the oxidized product. Okay. There is one more Cannizzaro reaction. It's called crossed Cannizzaro reaction. So instead of that is C6H5CHO, you can use benzaldehyde also. Not benzaldehyde, formaldehyde. In place of this, you can have HCHO. When you use HCHO, you will get HCOOH as the byproduct. Okay, and you will get benzyl alcohol. So let me write separately. Crossed Cannizzaro reaction. Okay, so you can remove this benzaldehyde. Instead, you can take HCHO. Okay, and here you are able to get HCOH, formic acid. That's all. So this is known as crossed Cannizzaro. Now let me ask you one simple question. How can you get benzyl alcohol using Grignard reagent? Can anyone tell me? Please draw and send the snapshot. And before attempting this, please go through my previous videos or notes you would have already noted down, where from you can get the clue for this question. Try this quickly. Can you do it, or let me explain? So you can start from HCHO, that is the starting compound. For always benzyl alcohol, what is the formula? C6H5CH2OH, which is nothing but primary alcohol, is it not? So this C6H5OH can also be represented as phi. So you can simply put 5CH2OH. But you must mention phi is, that is C6H5. Right? Now you have HCH double bond O. And here you have to consider the, instead of RMGR, you have to take C6H5MGR. C6H5MGBr. That is phenyl magnesium bromide. Now you can cut this. So plus minus pi electron transfer. Now C6H5 will go here and MGBr will come here. I hope now you can proceed. So HC single bond, and what about this? This is C6H5, and then this one is OMGBr. Now undergoes hydrolysis so that you are able to get C6H5 CH2OH. Okay, C6H5 CH2OH, right, plus MgBrOH. Got it? Do you understand now? So shall I proceed to the next reaction? Right. Reactions of benzyl alcohol. Benzyl alcohol. The famous reaction is reaction with sodium and the reaction with chlorinating reagents. Chlorinating reagents or that is PCl5, PCl3, that is phosphorus pentachloride, phosphorus trichloride, and sulfuryl chloride. So you have another reaction, that is esterification. Esterification means a reaction with acid. Being an alcohol, it can react with acid to give ester. Now let us proceed with the first one, reaction with sodium, so that you can get C6H5CH2OH. On reaction with sodium, you can have sodium benzoxide, 6CH5CH2ONA with the removal of hydrogen. Okay. Then reaction with the chlorinating agent. So what are chlorinating agent? Chlorinating agent, there are three major chlorinating agents. One is PCl5, phosphorus pentachloride, phosphorus trichloride, and you have SO2Cl2 also. Okay. Alcohols, phenols, ethers, it's a very big topic. Now, let me take the benzyl alcohol. So there is a standard reaction here. C6H5CH2OH. Okay. So here PCl5. So PCl5 will join like this. PCl5, that is PCl3, here Cl, here another Cl. So it breaks like this. Okay. This is not a mechanism, but this is for our convenience we write. So C6H5CH2 is a very good chlorinating agent. So chloro, what is that? Toluene we are able to get. Then plus here, that is benzyl chloride, not toluene, benzyl chloride or toluol chloride. This one POCl3, that is PCl3 plus O, POCl3 plus HCl. So remember, these two are the standard byproducts. Along with that, you will get the chlorinated compound. Okay. Shall we proceed? Okay. Next one. You know something about the esters based on benzyl alcohols. Now let me write the reactant. You have to tell me the product. C6H5COOH plus HOCH2C6H5. What could be the product? Anyone? Name the compound. Name the compound. What is this anion? Benzoate anion. And this is benzyl group. This is benzoate anion C6H5COO minus. What about this benzyl group? Okay, so it should be called benzyl benzoate. Right? Benzyl benzoate. Can anyone get me benzyl acetate? The process is esterification and the product is the respective ester. So I want benzyl acetate. Please write down the reaction, esterification, and send it in standard 12 in Telegram. What happened? Type my question, please. Can anyone type my question? What I asked? I asked, it seems ethyl benzoate, is it not? Not ethyl benzoate, benzyl acetate. Benzyl acetate. So Shreya has sent something. Benzyl acetate. So here it is wrong. It should be C6 benzyl acetate. What is the formula? First write down the formula. Benzyl. Benzyl means C6H5 CH2. This is benzyl group. Acetate is CH3 COO minus. Is it not? So you have to join. So how to write down this? That is CH3. This is acetate anion, and this is benzyl group, C6H5 CH2 group. So you have to add these two. So CH3 C double bond O and then CH2 C6H5. Now how to start this? You have to start from acetic acid, CH3 C double bond O. OH plus OH CH2. I have already given a standard procedure. You have to follow that strictly. So the OH will go here. You have to take that OH and here H. So minus H2O, so that you are able to get CH3 C double bond O and then O CH2 C6H5. Is it clear? Now you can call it a benzyl acetate, otherwise benzyl ethanoate. Okay, head down. Okay. Okay. Next, Let me write some aromatic compounds. You have to name the compounds very quickly. Okay? Try to name it. You can type. So here, let me draw the diagram. Name the compound. Let me say compound 1 and this one. Compound 2. Then this one. Compound 3, this one. You just number and send the name. Put the number and send the chemical name. OH and this is OH. Okay. This is fourth one. Try that. So all these 4. Do it quickly. Go one by one. What is the first one? The first one is called, anyone? Catechol. The second one is called, anybody? Hydroquinone or quinol or hydroquinone. Okay. The third one, what is that? This is known as quinone. Fourth one, anybody? That is called resorcinol. So these are all dihydric phenols. Okay. Now let me continue the next set. At least try this. OH, OH, OH. Fifth compound. And then OH, OH, OH. And then this is the sixth compound. Sixth compound, OH, OH, OH. This is seventh one, right? And you should know something about this compound, OCH3, eighth compound. Try this. So you can try all these things. You can refer book also and mention in the comment column also. Okay, so just number it 1, 2, 3, 4, 5, 6, 7, 8, and against which you can indicate the name. First, draw the structures. All these structures are available in your book. Please refer and type the name in the comment column later. Next, I'll go to the next one. So these are all very interesting one. You have to name it. Ninth one. These are all very popular aromatic compounds. This you know, 9, and this also you know, 10, okay, and you should know this compound also. It's a very famous compound. Right? And of course this compound is not stable. This is not stable. So when it is not stable, you can put like this. Not stable, but you have to give the name. And this undergoes dehydration to give this structure. And you have to get me the name of this compound. Okay, this is 12 and 13th. So these are all the challenges I am giving you. You can refer any book and let me know. And this you know already. This is the 14th structure. So draw all the structures. I had to include another structure. So it's okay. Shall we move? So you can give me the name later. Don't worry about that. And see, the another important compound to be discussed is phenol. The phenol can be prepared from benzene. So this is the most frequently asked question. Okay, please take down. take down this question. How is phenol obtained from benzene? It's a very important question. So please take down this. Actually, this is an industrial preparation. Okay. So this is an industrial preparation. Industrial preparation. Here, let me start from benzene. Benzene plus propane CH2 CH3 CH2 CH3 propane in presence of aluminum chloride. Okay. You are able to get the Friedel Crafts alkylation takes place. Alkylation in this case, isopropyl benzene. Okay, so this is called cumene. Cumene is nothing but isopropyl benzene. Isopropyl benzene. Isopropyl is represented like this. So which is nothing but CH3. Let me write here CH3 C CH3 H. Okay, so that has been simply modified like this. Okay, so isopropyl benzene. So when it is subjected to hydrolysis in presence of acid, not first you had to oxidize, then hydrolysis, followed by hydrolysis. Using a suitable oxidizing agent, you are able to get cumene hydroperoxide. Okay, so what is the structure? Take down. This is the benzene, and here you have C, and then here you have CH3 CH3. Okay, the same thing. Now instead of H, you can have OH. This is called cumene hydroperoxide. Cumene hydroperoxide, and now it is further hydrolyze it in presence of acid. Okay, so this CH3COCH3 will come and the OH will join. So let me draw like this. Okay, this OH will join here, so that you are able to get phenol. Are able to understand this? So you have to practice this. CH5 OH here, and this is available as byproduct, which is nothing but acetone. So CH3, C double bond O, CH3. So this is acetone and this is phenol. Okay. So this is a very significant industrial preparation of phenol. Remember this will be asked in problems also. Okay. So if you've got any doubt, you can ask me. We will continue the next part tomorrow. So thanks for watching this video. Good night.